അത് പോയിടും.
Excuse me, sir. Sir, you've been muted.
Sir, your audio's muted.
Okay, that's all right. Okay. So mole fraction is the ratio between the number of moles of the components and the total number of moles of all the components. So we can write the ratio mole fraction like this. Say mole fraction X is equal to number of moles of the component. Number of moles of the component by total number of moles of all the components. Total moles of all the components. That is the relation used. Mole fraction is equal to number of moles of the component by total number of moles of all the components. You take a binary system, a binary solution. There are only two components. Say the mole fraction of a component 1 is equal to x1. Mole fraction of a component 2 is equal to x2. So, take a binary solution with the number of moles of each component n1 and n2. So a binary solution with n1 and n2 number of moles. We have two components in the system. Number of moles of component 1 is equal to n1. Number of moles of component 2 is equal to n2. So what will be the mole fraction of the component 1? Mole fraction of the component 1 x1 is equal to number of moles of the components. Number of moles of the component is N1. N1 by total number of moles of all the components. There are only two components, so N1 by N1 plus N2. That is the mole fraction of a component 1. X1 is equal to N1 by N1 plus N2. The ratio between number of moles of the component and the total number of moles of all the components. So, there are two components with the N1 and the N2 number of moles. Mole fraction of a component 1 X1 is equal to each number of moles N1. So, N1 by total moles N1 plus N2. Similarly, say the mole fraction of a component 2, mole fraction of a component 2 X2 is equal to its number of moles, that is N2 by N1 plus N2. That is the mole fraction of the second component. X2 is equal to N2 by N1 plus N2, mole fraction of the second component. Now you take the sum of the mole fraction of all the components. That is here, X1 plus X2, take the sum. Sum is equal to 1. X1 plus X2 is equal to 1. And that is useful for Hello friends, there was a power interruption. So, let us go back to the mole fraction. We have two components. Then mole fraction of component 1, x1 is equal to number of moles of the component 1, n1 by n1 plus n2. And the second relation we had seen, I am writing this again, x2 is equal to n2 by n1 plus n2. Now, we have one more relation, that is x1 plus x2 is equal to 1. So, if you know this relation, from the relation x1 plus x2 is equal to 1, if we get the number of moles of one component, then we get not the number of moles, mole fraction. If one mole fraction is known, we can easily calculate the second mole fraction also from this relation. Say for example, if x1 is known, then x2 is equal to 1 minus x1, like that. Or if x2 is known, then x1 is equal to 1 minus x2. That is what I told, that if one mole fraction is known, we can easily get the second mole fraction. So these are the equations to be remembered. x1 is equal to n1 by n1 plus n2. x2 is equal to n2 by n1 plus n2. And the third equation, x1 plus x2 is equal to 1. So, to solve the problems, we have to meet one more problem here. That is, how to calculate the number of moles. You need not be given the number of moles directly. You may be given only the masses. Masses of the two components may be given. And then you will be asked to calculate the mole fractions. Then what you have to do? We have to calculate the number of moles of each component. So how can we get the number of moles of each component? If the mass of the components are given to us, how can we calculate the number of moles? And there is an equation for that. Do you remember that equation? Okay. Say number of moles is equal to mass in gram, mass of the substance in gram, mass in gram by molar mass, molecular mass or molar mass. Mass in gram by molar mass. That is the equation to calculate number of moles. You will be given only the masses. So from the masses, first we have to calculate the number of moles. To get number of moles is equal to mass in gram by molar mass. From this we can calculate the mole fractions of the various components. Let us take an example for this. Let us try to solve a problem. You please write down the problem. Calculate, you write down a problem. Problems will be asked for the examination. Okay. Calculate the mole fraction of ethylene glycol. Ethylene glycol. Mole fraction of ethylene glycol, molecular formula is C2H6O2. C2H6O2. That's the molecular formula of ethylene glycol. In a solution containing 20 gram of, in a solution containing 20%, in a solution containing 20% C2H6O2. C2H6O2 by mass. C2H6O2 by mass. Say the solution is in water, suppose. Solution is in water. No solvent is given here. Similarly, solution of ethylene glycol, only that one is given. So under such circumstances, what to do? We have to take water. Water as the second component. But if the second component is given, definitely you can use it. If simply a problem like this is given, only the percentage of the solute ethylene glycol is given and nothing else is mentioned. The second component is not mentioned, the solvent is not mentioned, then you take water as the solvent. Okay. Now let us find out the mole fractions of ethylene glycol and water in this. How to calculate? First we have to find out the number of moles. First we have to find out the number of moles. So you find out the number of moles of ethylene glycol first. So write number of moles of C2H6O2 is equal to, what is the formula used? Mass in gram by molar mass. Mass in gram by molar mass, that is the ratio. Here 20% by mass. That means if you take 100 gram of the solution, 100 gram of the solution, there will be 20 gram of ethylene glycol. So 20 divided by molar mass of ethylene glycol. It's not given, but the formula is given. From the formula, you calculate the molecular mass. C2H6O2. Carbon atomic mass 12 into 2 is equal to 24. Hydrogen atomic mass 1 into 6 is equal to 6. Oxygen atomic mass 16 into 2 is equal to 32. Now you add all this. Can say that the molecular mass is equal to 62, that is equal to 62U. 62 unified mass. That is the molecular mass of ethylene glycol. So a number of moles of C2H6O2 is equal to 20 by 62. You have to simplify and get the value. Simplify and get the value. The value is, you cannot use calculator. You cannot use even the logarithmic table also. You have to do the rough work in your mind. Sometimes the relevant logarithms may be given, not sure. So you find out the ratio of this, and it is equal to 0.322 roughly. 0.322, that is number of moles of ethylene glycol. Now you find out the number of moles of the second component, the solvent, water. So what will be number of moles, right? Number of moles of H2O. The solvent is water. Is equal to mass of water. Say in the problem it is given 20% by mass. So if you take 100 gram of the mixture, 100 gram of the solution, there will be 20 gram of ethylene glycol and 80 gram of water. So number of moles of water is equal to 80 by molar mass of water. You know what it is? H2O. molar mass, it is equal to 18. So 80 by 18 and the value is 4.44. That is a 444. It will go on like that. That is a number of moles of water. Now we can calculate the mole fraction of each component. You calculate the mole fraction of ethylene glycol. So, you take X2, that is a C2H6O2. Why I have written 2? Do you remember the norms that I follow? 1 for solvent and 2 for solute. Here solute is ethylene glycol. So its mole fraction is taken as X2. So X2 of C2H6O2 is equal to, I will get the number of mole fraction. Number of moles of ethylene glycol by total number of moles. Say X is equal to number of moles of the component by total number of moles of all the components. Here, number of moles of ethylene glycol is equal to 0.322 by total number of moles. That is 0.322 plus 4.444. That is mole fraction of X2. And the mole fraction of ethylene glycol X2 is equal to, you simplify this. On simplification, the value will be, you have to calculate and simplify. You just check it at your home after the class. The value is 0.068. 0.068. That is the mole fraction of ethylene glycol X2. Now we find out the mole fraction of water. Mole fraction of water. We can calculate the mole fraction of water in a similar way. You call it as X1. Mole fraction of water X1 is equal to, one method is this. One method is this. Number of moles of water by total number of moles. 4.444 divided by 0.322 plus 4.444. That is one method. What is second method? We know X1 plus X2 is equal to 1. That is a simple method. That is the simpler method. X1 plus X2 is equal to 1. Therefore, X1 is equal to 1 minus X2. 1 minus X2. That is equal to 1 minus 0.068. And that's equal to, you simplify that at least. Simplify. What is the value? What is the value you get? You take the difference. What is the value? Okay, the value is 0.932. 0.932. That is mole fraction of water. Definitely you can calculate the mole fraction in another way, as I told. That is number of moles of water by total number of moles. That means 4.444 by 0.322 plus 4.444. That is also a method to calculate number of moles of water. That is rather difficult. But the second method is very simple. That is 1 minus x2, that's equal to 1 minus 0.068, that is equal to 0.932, that is mole fraction of water. So that is the method. So such problems will be, simple problems will be asked for the examination also. Okay. Now, let us go to the sixth one, that is molarity. Sixth one, molarity. Molarity of a solution. Molarity, a term very frequently used to express the concentration. Molarity. The representation of molarity is capital M. The symbol used is capital M. And what is molarity of a solution? Molarity of a solution. It is number of moles of the solute per liter of the solution. So molarity is number of moles of solute, number of moles of solute per liter of solution, per liter of a solution. Number of moles of the solute per liter of the solution, that is molarity. Number of moles of the solute per liter of the solution. So, the ratio, the relation used is this. Molarity M is equal to number of moles of solute, moles of a solute by volume per liter of the solution, by volume of solution, say solution in liter, that is the unit used, per liter of the solution. Number of moles of solute by volume of the solution in liter, that is equal to molarity. Moles of solute by volume of solution in liter, the unit is liter, that is volume of the solution in liter. If you are given the volume in ml, milliliter, you have to convert that volume into liter by dividing with 1,000, because 1,000 ml, milliliter is equal to 1 liter. So, we have to convert the volume into liter if the volume is not directly given in liter. So, the definition may be number of moles of solute per liter of the solution, or we can have the equation. Molarity capital M is equal to moles of solute by number of moles of solute by volume of a solution in liter. So what will be the unit? The unit of a molarity. Unit of a molarity. What is the unit? Unit of a molarity is equal to, what is it? Moles per liter. See, look at the top. Moles of solute. Moles per liter. So the unit is mole per liter. That is the unit used. Mole per liter. That is number of moles of solute per liter of the solution. Remember, solution. Don't simply say solvent. Solution. Number of moles of solute. Definitely you say solute. Number of moles of solute per liter of the solution. So, mole per liter, that is the unit of molarity. Then, there is a problem with molarity. See, in the numerator, there is number of moles. Mass by molar mass. Mass by molar mass. That is number of moles. But in the denominator, there is volume. Volume will change with the temperature. When temperature increases, volume also increases, expansion. When temperature decreases, volume decreases. So volume is related to temperature. Even if it is solution, volume is related to temperature. Volume depends on temperature. So the problem is this. Molarity term depends on temperature. Molarity depends on temperature. Depends on temperature. That is the limitation, the drawback. The question may be, say you will be given, say, concentration terms like this, parts per million, mole fraction, then molarity, then mass percentage, all these terms will be given. And you will be asked, which concentration term depends on temperature? Say, molarity, that concentration term depends on temperature. Why? Because volume term is involved. Because volume is involved. As we know, volume varies with the temperature. In the denominator, there is volume term. So even if you are taking, Nandana is looking at the clock, you just remove the clock from there. Okay, I know that I have to stop at the 3:30, that I know, but I will finish this. Okay, so volume term depends on temperature. It varies with the temperature. So molarity also varies with the temperature. Although we are taking a definite amount of the solute, the concentration molarity varies with temperature. When heated, volume increases, molarity decreases. When cooled, volume decreases, molarity increases. So it is not a constant term, but at the normal conditions, that is a room temperature condition, the volume does not vary much. So we can take it as a constant, more or less a constant. But to be more specific, it depends on temperature. It varies with the temperature. Now we have to solve a problem based on this that we can do in the coming class. So remember this relation, molarity is equal to moles of solute by volume of solution in liter. The unit is mole per liter. And the number of moles is equal to mass in gram by molar mass. So we can do a problem in the coming class. For the time being, let me stop. Thank you.